NASA says it's Voyager 1, the most distant human-made object in the universe. Among the vast unknowns of space, one mystery stands out as perhaps the most bizarre: fast radio bursts. These phenomena continue to confound scientists, sparking endless curiosity. The realm of space exploration has always been a blend of awe, terror, and profound scientific wonder. But every so often, something happens that seems to shatter the boundary between science fiction and cold, objective reality. Voyager 1, launched in 1977, has been a silent traveler through the interstellar void for decades. This humble probe, no larger than a small car, has ventured beyond the influence of our sun, sending back precious data from realms no human or machine has ever touched. Over time, its transmissions had grown faint, its systems aging, and many assumed its mission was quietly coming to an end. Then something extraordinary occurred. A surge of unusual telemetry activity reignited interest in the aging spacecraft. What happened next defied every expectation. Voyager 1 transmitted an image, one that was unlike anything previously received. This was not a glitch or corrupted data packet. It was an organized, coherent transmission that appeared to show something constructed, something intentional. Physicist Michio Kaku revealed that AI systems analyzing the data had reached an unsettling conclusion. The image may have originated not from a natural source, but from an unknown intelligence. Something or someone was responding. The sequence began without drama. Ground control at NASA received what seemed like a routine data burst, one of the countless small packets Voyager 1 has been sending for decades. But this time, something was off. The AI monitoring the telemetry flagged the packet for further analysis. Its structure did not match anything previously seen. The signals, modulation, the way the radio wave carried information, was strange. At first, engineers assumed it was a malfunction, perhaps due to degradation of the probe's aging hardware, but deeper analysis by NASA's Deep Space Network told a different story. The signal wasn't corrupted, it was structured. It displayed patterns consistent with digital encoding, layered redundancy, recursive sequences, and error correction routines were all present, hallmarks of deliberate, engineered data. As AI models trained in deep space signal recognition decoded the packet, a startling revelation emerged. The data formed an image. Not a photograph, but a compressed, vector-based representation, geometrically encoded in binary. When fully reconstructed, the image was haunting. Against the pitch-black backdrop of deep space, expected, given Voyager's immense distance from any nearby star, there appeared a faint, illuminated structure. It was not random. The shape was symmetrical, lattice-like, and complex. It pulsed in high-frequency bands, suggesting an engineered origin. Michio Kaku, briefed on the findings early on, confirmed that AI analysis ruled out natural origins. The pattern did not resemble cosmic radiation, background noise, or any known astrophysical phenomena. More remarkably, the signal appeared to mimic Voyager's own language. That detail changed everything. It meant this wasn't a random signal, it was a response. Someone or something had heard Voyager's long, lonely broadcast, and they had answered. This opened the floodgates to questions scientists were unprepared to face. Voyager had long since passed the heliopause, the boundary where the sun's influence ends. Beyond it lies true interstellar space, a realm where we expected Voyager would drift silently for millennia. It wasn't designed to initiate communication, only to send basic telemetry home. So who, or what, was capable of detecting and replying to such a faint, low-powered transmission? And more importantly, why reply in such a cryptic, calculated way? The mystery deepened as AI systems uncovered more layers within the transmission. The image wasn't just a picture. It contained what looked like logic diagrams, recursive patterns resembling early Earth-based communication protocols. These patterns hinted at more than intelligence. They suggested understanding, symmetry, logic, even design. Aesthetics were Present. Embedded within the binary code was something even more curious: elements of trinary encoding. That's a three-symbol information system, unlike the binary 0 south and 1 south we use. Such a system might indicate an entirely different kind of computation, one potentially more advanced than our own. Scientists began to see a disturbing possibility. This was not a mistake. The signal was crafted, methodical, and purposeful. Whoever sent it had not only decoded Voyager's language, they had built a response in kind. As the realization spread, the world paused. This wasn't a blurry UFO sighting or speculative anomaly. It was hard data, digital, structured, and mathematically consistent. A signal from billions of miles away, showing hallmarks of design. Kaku emphasized that while the AI decoded the content, it was the philosophical implications that truly shook the scientific world. Someone, somewhere, had heard our whisper in the cosmic dark. And they replied. The scientific community quickly became divided. Some researchers urged caution, warning that natural phenomena might still be responsible, that we could be misreading patterns due to our own cognitive biases. Others countered with the growing mountain of evidence, the clarity of the patterns, the confidence metrics from the AI, and the unmistakable structure of the response. The turning point came when researchers discovered a second layer within the image, a map. This wasn't just any diagram. When mapped using astrophysical coordinates, its points aligned with known gravitational anomalies, strange distortions recorded by Earth's deep space observatories over decades. Previously dismissed as dark matter fluctuations or statistical noise, these anomalies now appeared as reference points in a larger galactic system. The image may not have just been a reply, it might have been a map, a kind of galactic positioning system, or a network. This changed the question entirely. We no longer wondered who replied to Voyager. We began to wonder how long they had been listening. Michio Kaku addressed the implications head-on. If this intelligence had intercepted Voyager's signal, it either had technology far beyond ours, or it was much closer than we had assumed. And if they responded with such tailored precision, we may have unknowingly become participants in a larger interstellar network. To them, Voyager may have looked like a probe, a drifting artifact sent by another civilization, not so different from how we would interpret a mysterious object floating into our own system. Carl Sagan had once envisioned a cosmic internet, civilizations passively listening, waiting for the right signal. Perhaps Voyager had sparked just such a moment, but the nature of the signal raised tensions. Was this contact peaceful, neutral, even hostile? The image gave no definitive answer. It wasn't threatening, but its ambiguity was unsettling. An intelligent reply, using our own probe's transmission to return a message, suggested not just awareness, but observation, evaluation. Even, after all, Voyager carried the golden record, a time capsule of Earth's languages, cultures, music, and science. Had someone finally opened it, further examination revealed even more complexity. The encoding structure of the signal had subtly evolved. It appeared not to be a single transmission, but a stream, something dynamic and possibly adaptive. AI systems noted metadata tags, version numbers, and even built-in error correction. This was no rogue signal, it was a tiered information payload. It hinted at a mature, deliberate information-sharing culture, one far more advanced than ours. NASA, though cautious, confirmed the signal's authenticity. Their internal reports, though not fully public, acknowledged the reconstruction of the image and its unusual structure. One eerie discovery stood out. Part of Voyager's earlier broadcasts had been embedded in the response, as if the sender had reflected it back, a subtle, deliberate acknowledgement. A cosmic handshake for many scientists. This shattered the old assumption that deep space was empty and silent. Voyager, after nearly half a century, had seemingly crossed into something unexpected. An inhabited space, or at least a watched one. The timing, the structure, and the feedback loop suggested we were not just observers of the universe. We had become part of a dialogue. There was something haunting, even beautiful, about it, that a machine launched by humans before the internet, before smartphones, before the Cold War even ended, had managed to awaken something out there. It marked a turning point in our story as a species. We were no longer just broadcasting into the void, we were receiving. We were being heard. Kaku warned that our role in the cosmos must now be reevaluated. If we were under observation, then our scientific, ethical, and diplomatic frameworks must extend beyond Earth. We were no longer alone, not in theory, but in fact. And with that awareness, everything changed. What followed was not another image, but a series of pulses, rhythmic, structured, and deliberate. Early interpretations suggest it may be a primer, a teaching tool, perhaps a test. It resembled the start of a tutorial. Voyager, always the ambassador, had become a bridge. The silence that followed this message felt less like an ending and more like anticipation. Was the transmission complete? Was it awaiting a reply, or was it testing if we even understood what had just happened? AI systems continued to scan every new packet, every fluctuation, every echo. The scientific world is holding its breath. What comes next may change the trajectory of humanity forever.